In this lesson, we are going to evaluate the integral of sin³ using a combination of trigonometric identities and integration techniques. We'll start with rewriting sin³ of x using trigonometric identities. Our goal is to simplify the expression so it becomes easier to integrate. We can use the identity sin² x equals 1 minus cos² x. Next, we'll substitute this identity into the integral. So the integral becomes integral of sin x times 1 minus cos² x with respect to x. This effectively separates our expression into sins and cosines. Let's distribute sin x to get two separate integrals. This can be split into the integral of sin x with respect to x minus the integral of sin x times cosine² x with respect to x. At this point, notice we have one expression that is straightforward and another that still needs some attention. Now let's integrate the first straightforward part. The integral of sin x with respect to x is negative cosine x plus c. This comes from the basic integral rule for sine. Now, let's focus on the second part, the integral of sin x times cosine² x. We'll use substitution to solve it. Let's choose u equal cosine x, so do becomes negative sin x dx. Find the integral of negative sine of x cosine x squared. Notice the negative sign on the negative sign x matches the original substitution. And now we will express everything in terms of u. Now for the integration step. This integral simplifies to negative 1/3 times u³ plus c. Finally, we'll perform the substitution back in terms of cosine x, our original variable. So the evaluated integral is negative cosine x plus 1/3 times cosine³ x plus c. Let's combine this with our initial first integral to obtain our final answer. And that is our final answer. That's how to evaluate the integral of sin³ x. Thank you for watching.